Okay, so first I'm going to give some quick announcements, and we'll get into this example. So quiz 2 was, will be posted as soon as this lecture is over. Quiz 2 will cover things from last week and from this week. So it's a little bit longer. There's 5 whole questions on it. You may take it with feel free to take the quiz like right after class. You can just like take it outside and just knock it out. Shouldn't take too long. Yeah, 5 questions. Cool. So other thing is, so homework 3 is due tonight. Homework 3 is fairly long. A lot of people have been struggling with homework 3. The biggest problem I've seen people face I mean, that's fine, but that is not going to be a long-term solution. I would recommend figuring this out and getting the paths set up, because ideally, like all source code, like every project structure will always have like a source directory, and your CMake will have a path, like it will specify the path into the source directory. Yeah, so it's still important. Yeah. Okay. Cool. Good. Done. Another thing, so homework 4 is technically due on Friday of next week, but please just finish it as soon as possible. The sooner you finish it, the sooner you can start your final project. I will spend all of next week, or at least the first couple days of next week, going over what the final project will be. Hope you're all super excited for it. The main thing that we need is your GitHub repository for the instructors to drop starter code into there. And once you receive your starter code, then you can begin working on the project. So please submit homework 4 as soon as possible so that TAs can do that. Okay, good, cool. So let's go back to this maps example. Before we run this, let's create a target for this in our CMake lists. So here I already have an executable that I have. It's for ref.cpp. We'll take a look at this in a second. But really quick, how would I create a new target now to compile this maps.cpp using CMake? Anyone? What line of code, or at least what function do I need to be running here? Okay, yeah, yeah? Or is your stretching? Okay, yeah, yeah. Yeah, so we need to add executable, but but this executable is already, this is an executable called main. In fact, maybe we should be calling it ref. What we'll need to do instead is we'll need to create a new executable, because we want to create a new program that will run a new main, because here's main right here. We want to run this main. So yeah, so what I'm going to do is I'm going to create a new executable, and I'll pull in, I'll call it maps, and it will be compiling maps.cpp. Okay, and you can see I am, actually, let me go back. Okay, so, and of course, anytime that you ever run CMake, you should always do it from a build directory. So I'm going to quickly create a build directory. So make dir build, okay? And then I will cd into build and run CMake ... okay? And now it is compiling, it is creating all of the make files now. So now what I can do in order to build the maps project, I can just type in make maps. And now this will create the executable. You can see it's compiling this maps.cpp, linking everything, putting it together. Perfect. So great. So now we have access to this maps executable. Okay. We'll be spending a little bit more time talking about CMake as the quarter goes on. I just want you to be starting to feel a little bit more comfortable actually writing things in the CMake file. Eventually, your CMake files will get longer and longer, especially as you start pulling in third-party libraries. So sprinkling in just a little bit of getting started. Okay, let's run this. Okay, I'm sure you're on the edge of the seat, wondering what the output will be. Okay, so I'll tell you what is unique about this. So here I am creating 2 entries into this hash table. So that you can see I have an entry at the key apple, and I have an entry at the key banana. So then when I go and print out the entry at apple, what would you imagine should be printed out on this line? What will be printed out? Sorry. What will be printed out on this line? Shout it out. 10, thank you. Okay, and then the next line, what is next? 20, okay. On the next line, well, we haven't declared anything there yet. Okay, so what would you imagine? Maybe it'll say maybe it'll be a seg fault. Maybe it'll say out of range, or maybe, I don't know, maybe it'll insert there something automatically. Okay, but then we have this other thing where instead of doing square brackets, now it's saying .at. Okay, so maybe that's doing something different. Okay, let's see what happens now when I run maps. I'll expand this out a bit. Okay, and boom. Good. So, okay, so looks like our first 2 lines, we were correct. So it printed out 10, then 20. Then it prints out 0. Okay, weird. And then it gives an error. And this is because just C++, the way that maps work, and this is something that you will definitely see more of, is anytime you ever use this square bracket operator, that means that an entry will be inserted into your map automatically. So even though we are trying to fetch the data out of Peach, what ends up happening is first, we check, does Peach exist? And if Peach does exist, then we will grab it. But if it does not exist, then we will run the default constructor on it. So the default constructor of an integer produces the number 0. So that is why it then prints out 0 here. Yeah. And however, that's different when we do .at. What .at will do is it will not try to insert an element. Instead, it will just check does that element exist? And if it does exist, then it will give us that element. But if it does not exist, then it will throw an exception. Cool. OK. Good. Kind of cool. And it's kind of a weird kind of C++ thing, kind of important to be aware of. I'm sure that many bugs have just been solved by me showing you this now versus you trying to figure this out later. Okay. It'll probably be on your quiz, so keep track of this example. OK. I'm going to move on, unless anyone has any questions. Yeah?
So how do you check if it exists if you want to see if each exists?
Yeah, great question. So how would we want to now check if an element exists? So there's a couple ways that we can do it. Probably the best way is to do std find. And we can pass in the hash table, and we can do .begin and then .end. And what this will show us, what it will do is we'll iterate through the entire length of our hash table, and what we can do is type in what we want to find. So maybe we want to find banana, and then in this case, it will return back the iterator to whatever place has the element banana. So I'll call this banana it. OK, cool. I'm getting an error. Oh, right, because I just need to include algorithm. Yeah, cool. And if this banana does not exist, maybe instead I'm looking for bananas or something. So if this does not exist, then we can check this, and we can say if bananas is equal to the end of the array. Because if it does not find the element, then it will just set it to the end. So we can say, so if it's equal to that, then it's like not in the hash table. Yeah, good question. This is kind of the most popular way to check. Yeah, and I could spend like a lot of time going through the random details of hash tables, like unordered maps and maps. I think it's probably most useful for you to kind of spend your time just doing it in the final project. So feel free to, Google a bunch of stuff. I have a really great C++ resource that I will share with you, and I highly recommend going through that throughout the quarter. Yeah, another question?
Yeah, just one quick question. So it returns an iterator.
Mm-hmm.
If you were just to do like, finding it normally.
Mm-hmm.
Sorry. So if it doesn't exist, like it's not like it returns a Boolean, right?
Correct.
Okay. So how would you use this to check? Like, would you check if it's not empty? Or?
Yeah. So what we would do is we'd say bool like has bananas. It would be equal to this condition right here. It would say like if bananas does not equal to the end. Because if it does equal to the end, that means that it did not exist. Yeah. Cool. OK. Great. Hash tables. Great. They're a lot of fun. Now, what I want to show you is another kind of cool C++ thing. So when you create functions in C++, for example, these two functions right here, what you will often do is you will pass in some sort of parameter, some sort of argument into this function. For here, I am passing in this class. And you can see this class, it's very simple. All it does is it has a string, but this string is huge. It's 1 million x's all in a line. So yeah, this is a very large object. If we have 1 million x's, how many kilobytes will that be? Or how many megabytes will that be? Mega means 1 million. So therefore, this will be about 1 megabyte. Okay, this is a huge object. Usually, like when you're creating classes in C++, you don't want to do this. Like you don't want to be creating like a single class object that has an entire megabyte. Usually you're dealing with like a few bytes at a time. This is a huge object, and well, what happens is when we create a function that looks like this, where we just say like, oh, like pass in an object with type large object and then our object, what will happen is the copy constructor will be called. And even though here we don't have a copy constructor, instead the default copy constructor is called. There's a hidden kind of implicit copy constructor that is given to all classes like silently. What this copy constructor will do is it will actually, like in fact, copy over this string for us. So we didn't even need to draw out a copy constructor. It automatically creates a copy constructor for us. But yeah, so what happens is anytime we call this function, the copy constructor is called, and we get an entire new like megabyte of data created. And so we call this passing by value because we're passing in like the entire value of this object. We're not like passing the object itself. Instead, we're passing like the value that the object stores. And passing by value in C++ is generally frowned upon because most of the time you actually don't need to be sending like the entire value of your object. Instead, you probably just want to like read it. So it'd be better to instead just get like a pointer to that object. So here is the other type of calling or of receiving methods. Of receiving arguments into a function. It is called passing by reference. And when you pass by reference, you can see it's passing by reference with this little ampersand there. And what this ampersand means is, yeah, this object is now going to be a pointer, but it appears like it's just a regular object. So it's not doing like, this like arrow operator. Instead, it's just this dot. So it looks like it's a regular object, but it's actually a pointer. And we can throw on this const here just to say like, hey, like I'm giving you this pointer, but please actually don't edit it. Like just receive it, just read it in, but don't actually do anything with it. And this style right here, we call it passing by const reference. This is much more preferred in C++ than passing by value. This should be your automatic default. I know it's like kind of longer. You have to write const and then the ampersand. It takes a little bit longer, a few more keystrokes. But just by default, you should always fall back on this. To kind of hammer this in, I actually created this kind of simple benchmark program here, just so we can see the difference in the time it takes to run each of these functions. So this is, okay, wait, actually, any questions at this point? Feeling good? Okay. Okay, I'm going to show you the time that it takes to call each of these functions. Yeah, question?
I don't know if this also common in other languages, because I don't think I've ever heard any other languages with the side construction.
Yeah, so other languages, that's a good question. I feel like passing by const reference is not as popular in other languages, but with Python, anytime you pass any object or list or array or dictionary, those are all passed by reference. But if you pass primitive values like integers or floats, those are passed by value. That's specifically Python. I'm not familiar with like every language off the top of my head, but specifically in C++, I mean, that's another great reason why people love C++, is because you can specify exactly like what specific like copy constructors and like if you're passing by reference or const reference, you can be very like granular with this. Cool, okay. Let me also, another kind of side tangent, let me show you this function timer class that I made. We will talk about this later. Okay, it probably looks like complete magic at the moment, but you can see I have this timed result struct with a result. It has a result type, and then I also have this elapsed time, and I can get this elapsed time with this function elapsed nanoseconds. Okay, cool. And we can see we have this function timer class with all of these weird kind of things right here, and it's using cool kind of template stuff. This is really cool. I'll provide this file to you. You're welcome to look through it. C++, like, yeah, you can do all sorts of really crazy things. But effectively, what this is doing is now we can just call this time function, which will time like how long this takes to run. And what we can do then is take this reference by reference value member, and we can print out the elapsed nanoseconds. So this is how long it takes to pass the member by value, and then this will be how long it takes to pass the argument by reference. Okay, and now tell the person next to you, which one do you think will take longer? And in your opinion, how much longer do you think it will take? Okay, go and tell the person next to you. I'm going to compile this. Okay, cool. I'm going to run it. So that was pretty quick, but let's see. Okay, time by value. All right, this is huge. This is like almost 2 milliseconds versus by const reference, this is 300 nanoseconds. So you can see drastic speed differences by passing. I mean, granted, this is an entire megabyte. Like, that's a lot of data. It's 1,000,000 bytes that need to be copied over when we do pass by value. So most of the time, you're not going to have that issue. But yes, anyways. All right, cool. So now you know. Always try to pass everything by const reference. Yeah. Cool. Good. Feeling good? So that is all the C++ that I wanted to spend today. We're going to talk more about Git and GitHub next, unless anyone has any more questions on this. I'm going to pull up the next example. Great. So this was the GitHub repository that we made a couple days ago, if you remember. So I just pulled all these random files in, and I committed my files. And so you can see I have .gitignore, I have CMake lists, README. I have this green checkbox right here. What does this green checkbox represent again? Remember? Yeah? Exactly, yeah. So there's tests that I've included in this, and the green checkbox means that it's passing the tests. We can open up the test right here. We can see, so this is, a part of GitHub. It is running continuous integration where, I'm checking basically just that there's no trailing white space at the end of any of my files. Okay, cool. So this is just my kind of basic repository. Well, now let's say we want to edit some of this maybe. So I could now come in here and I could make a change. And VS Code is really, really great because anytime you make a change, like it's very clear exactly what lines you've edited because it puts this like little green box or maybe a little blue like marker that says like, oh, you've edited this line. And if I want at any point to like be like, oh, actually I want to undo this, I can click on this little thing and I can see like all the changes, but I can hit revert right here. If I hit revert, then you can see now it just reverts that one little change that I just clicked on. Yeah, really cool. And if I want, I can commit this change. Let me make something a little bit better. Hello, welcome to the sandbox repo. Maybe we'll say, take a look around. Okay, so now you can clearly see I have 2 lines that I've changed here. And what I can do is, on VS Code, you will have this little icon right here, and this is the Git icon. So if I click on this, I can actually see all of the changes that I've made. And you can see I've made a change to README. So if I click on this, it will show me, like it'll highlight very clearly. I've added these files. Now I can go and type in a commit message. If I wanted, I could also go on the command line and I could do like git add, and I can specify the file. Have people done this before, like doing git add and stuff? Yeah, okay, probably done this. In my opinion, I think it's just too error-prone, kind of difficult, and it takes a while to type it all out, especially if you're dealing with like 100 files in a single commit. Like sometimes you're dealing with really large projects. So what I really like to do instead is to use the GUI that VS Code provides you. So yeah, what I will do is I will click this plus icon, and this is the same thing as doing git add. And then now I have this staged, and now I can add a commit message. So I can just say improve documentation or something. You should always, like no matter what, you should always try to add a good commit message just so people know exactly like what you've changed. It just helps out other people. So now we can commit this if we want. Good, we've committed it. And if I want, I could now go and do git push. Or I could just click sync changes, still using the GUI. So I'll just click sync changes, and now this should just push everything now back to this repo. And if I check back, then go back to the main page, then you can see now it says I have 2 commits. And I have now added, this commit, improved documentation. And you can see automatically the continuous integration is already rerunning on this, on this commit. And the whole purpose of the continuous integration is just assigning a little checkbox whether a single commit is working or not. It won't necessarily like prevent something from being included in your tree. Instead, it will just like show you like, oh, like this commit is good or this commit is bad. Okay, good. So you've probably all seen this before. Oh, yeah. Mm-hmm. Mm-hmm. Yeah, so if you run multiple tests back to back, or if you make multiple like pushes back to back, then the job that is currently running will just continue running, but now extra jobs will just be appended to the job queue, and it will eventually kind of work through each one of your jobs. Yeah. Cool. Okay, so this was good, right? We pushed to main. This was a pretty kind of innocuous kind of change, not a big deal. What you should do, though, is probably actually never commit directly to main. And the reason for that is your main branch is meant to always be kind of a snapshot of like high quality code. You should never, like if you want to test something out, like if you want to maybe just throw in maybe some new ideas that you have of a new feature that you want to add to your code base, you should not put that in main. Because if someone now is like, oh, like, I saw this brand new emulator project that I'm really excited about, they go and download your repo and nothing works, and you say, oh, sorry, I was in the middle of adding this new feature, they're going to be pretty upset. So what a much better method would be is to create a Git branch called a feature branch. So I will show you how to do that. And in my opinion, now this is where I don't use the GUI, and I go back to command line. Okay. Might be good to kind of write down these commands as I type them out. But what I will do is I can do git, I can type git branch, and I can see all of the branches. So at the minute, I only have main. This is my only branch. But if I want to create a new branch, maybe I want to add some new change, then I can do git checkout, and then -b to create a new branch, and then I can call it something else. So I can call it maybe like better docs. Okay, and so now I have this, oops, I spelled checkout wrong. What was that? Yeah, I did. Okay, cool. Was that the question? Okay, good. So cool, so now it says switch to a new branch, better docs. Now if I do git branch, then now you can see I have 2 branches, but better docs is exactly the same as my main branch. Like I made a new branch off of my main branch. So if I now made a change to main, then my better docs branch will not be affected. Yeah, and in fact, maybe let's do that. So if I want to switch back to main now, so I'll do git checkout main. Okay, let's make a quick change again. So I don't know, maybe in git ignore, maybe we can add another file, maybe like .ds store. Okay, we'll chat about this in a second. So maybe I want to add this file to my main branch. Maybe this doesn't need a whole feature branch because it's just one single line. Now I can add this change. So I can go over to this tab. I can hit this plus icon. If I wanted also, I could add this change by going over to the specific line and click on the change, and then click this plus sign. I actually personally just like doing it this way, so I'm seeing exactly which lines of code I'm adding to each commit. So here I can stage this change. So now we can see I've done this, okay, and I'll just say in my git message, I'll say added .tsstore, okay, and I'm going to commit, and then I'll just hit sync again. Good. And so now we can see if I do git checkout, what did I call it? Better docs? Yeah. But also, Git has good tab completion. So yeah, you saw I just typed in B, and then I hit tab. There we go. So it says better docs now. Okay. So now I'm back on better docs, and we can see, once again, git ignore got rid of that change because main and better docs are on two different stages of my Git tree. So any changes I make on main will not affect better docs, and changes on better docs will not affect main. So yeah, it's kind of a nice little, almost like a little container for you to work nicely in. Okay, cool. So let's go and add some better docs to this now. So okay, take a look around. Maybe I'll say it's, I don't know, enjoy the weather. Yeah. Okay, great. So I've now improved documentation. Yes, question? Oh, yeah, so what origin is saying, this is just the default name that a Git branch is referring to when it's talking about some sort of Git server. So GitHub is referred to as origin here. So yeah, if I wanted to push to maybe a different server, maybe instead of calling it origin, I would call it, I don't know, Ethan's home server or something. Yeah, so origin is like the name of the Git server. Yeah, so there's no significance to the actual word, but yeah, so if we wanted, I guess we could, actually, yeah, okay, let's demonstrate this. So, okay, cool, so I've just added this change. So it now says enjoy the weather. So I can go and I can click on this, and now I can hit plus. So now I have staged this change. And maybe I also want to go and change something else now. I want to say, I don't know, okay. And then I go and save this and stage this change. And yeah, actually, okay, super quick, I'm going to do something kind of funny. Okay. Close your eyes for a second. Oh, sorry. Echo, read me. No. What am I doing? Guess. Okay. Okay, take a second, maybe look at that. Think about what example I'm going to be doing in a second. Okay, cool, okay. Okay, good. So now we can stage this, and I'll push all of this now. I'll make a commit, so I'll say added more, okay. Good. So now, instead of saying sync, now it says publish branch. And what publish branch is yeah, so this branch that I've created does not yet exist on GitHub. So if we go over to GitHub, and if I hit refresh and go over to my branches right here, you can see that my only branch right now is just main. And in order to push this, I will actually need to be more verbose with where I need to push to. So what I will do is I'll say git push. Then I need to say origin referring to GitHub, like this specific Git server, okay? And then I need to type in the name of the branch that I want to push to. And the branch will be better docs. Okay, and so now I'm pushing, and good, so it just pushed everything, and now I can go back to GitHub. There we go, and now we can see that I now have second branch, better docs, cool. We can open this, and we can see that it looks like it's all working. It says one commit ahead, but also one commit behind. This makes sense, right? We pushed one commit, but also we are one commit behind because we added the .ds store thing to main. Okay. We also see that we have this failure right here, unfortunate. Okay, so let me check this out. I can click on details, and I can see what's going on. So it says, okay, it says line 9 of my README, it says files cannot have white space. Okay, so let me double check. Maybe I did something wrong, right? Actually, maybe, yeah, no, that's fine. Okay, so what I can do is I can go into my README and I can find this spot. Yeah, here we go. Good. I can click on code to see, and yeah, anyway, so you can see right here, I actually have this space that I included. And that was the funny command that I did, where I was like, oh, like, look at this, imagine what example. Anyways, by adding this white space, now we can see this file is now failing the continuous integration. Yeah, there we go. Okay. Good. Feeling good? Right, so we've now made this awesome change, maybe minus the space, but let's maybe ignore this for now. How do we now get the branches to kind of like be back the same? Like, how do we now take our changes that we've just put on our feature branch, our cutting edge changes, maybe we've made a bunch of changes, and now it's finally working. How do we get this back onto main? Anyone know? Yeah, okay, tell the person next to you, what is the kind of the process of getting your changes from this feature branch onto main? Okay, tell the person next to you. Okay, keep that in the back of your mind. Really quick, I'm going to replicate if maybe someone else came along and wanted to also add some better documentation. So maybe someone else started out on main. So how would they, oh yeah, okay. So how does someone now switch to the main branch? What is the commit for that? Or what is the command for that? Git checkout main. Yeah, perfect. Okay, git checkout main. Okay, so now we are back on the main branch. So now you can see it's back kind of how we expected, so we can see this .ds store. Now what we can do is, if maybe someone else in your team wanted to make another feature branch, so I'll call this git checkout. How do we create a new branch again called like better docs 2? What do we need to do? Yeah, -b. Okay, -b, and better docs 2. Okay, and good. So now we're on this new branch, and then maybe I can say hello or something. Okay, cool, good. Now we can push this, or first we need to commit it. Okay, I'm gonna commit this. Okay, changes. Good. Don't name your commits like this. Okay, and then we push it with git push origin to refer to GitHub, and then better docs 2. So now we have pushed this better docs 2. Good. Okay. Now let's switch back to our better docs. Okay, so now we're back on better docs. We can see that everything is starting to look a little bit better here. What we will now do, though, is we will we will do a pull request to merge the changes from our first better docs branch into main. So that is the method for taking changes on a feature branch and putting them into your main branch. It's called a pull request. And you can see GitHub has a really nice big green button right here that tells you how to create a pull request. So we can just click on this right here. So let's compare and create pull request. So great. So this is the screen of what a pull request will look like. And so we can see all of the changes that happen. So we can see, take a look around, remove this line, all good. We can add probably a better title. So we can say added more documentation, okay? And if we want, we could add a more detailed description. Maybe if you were doing a pull request in your repository, maybe you would want to link to some documentation or something that you found from something. Okay, now you click Create Pull Request. Good, so now we have this screen. You can see that the workflow was probably rerun. We can see it's failing, so okay, that's not great. But we've completed the creation of our pull request. Now, the next step, I guess, would be to fix all of the failing tests. Let's imagine that we've done that. But the next step would be calling up your friend or messaging them on Discord, saying, "Hey, can you help me? Just give me a second pair of eyes and look over my changes." And so you'll take like this link right here, maybe you'll copy this, put it in Discord or iMessage or whatever thing you communicate with your team with. You send this to your group chat, and now your teammates will look through your changes. They'll go and maybe they'll look at files changed, and they'll see every single change that happened, and they will read through every single line and maybe make a little suggestion every once in a while and be like, oh, like I think you should rename this function to make it more consistent with this other thing. So they can come in and add comments, and I will show you how to make a comment. So if I wanted, I could add this comment right here, and I could say, why does it say ah? Right, okay, sure. If I want, I could also add a suggestion with this little icon right here, and if I click that, then this is what it will look like. So you can see it has ah as like the default, but if I want, I could just change it to now be blank. So now I can do this. I can preview it as well. So you can see the suggested change is now to just remove this ah line, okay? And now I can click Start Review. So this is now, you can see it's pending, because I've started a review, so I'm now like, maybe I'll go keep scrolling through and keep making more comments on everything. When I finally made all of the comments, then I click Finish My Review. And if I wanted, I could say like, oh, like everything was perfect, and say no comments, and then you could click Approve. But in this case, since I made a comment, I cannot just say like approve. Instead, I will need to just leave it as comments, and I will click Submit Review. And now it will be sent over to your teammate, and your teammate will see all of the changes that you would like made. Yeah, cool. And so now, if putting back the original, the PR creator's hat, you can now see right here, it's like, oh, okay, you know what, I do agree with this. Maybe I'll go and include this change that they suggested. So now I can right click, or I can click on this, and then now I can click Commit Changes. And so now you can see I actually just created a new commit right here. And this new commit will pull in the changes that were suggested right here. So you don't even have to go back to your like VS Code to do the commit. Instead, you can do all the commits like directly from GitHub. Yeah, cool. Okay, we're still failing this test. Let me quickly show you. So let's go and fix that other test from GitHub. So I can go back to Files Changed. We can see that we're failing this because of this. Come on. Come on. Okay, it's not working. That's okay. All right, good enough. Okay, cool. So if I want to remove that last line, there we go. I just removed it. So I can do Start Review and Finish My Review, Submit Review. So now I've requested to remove this one trailing white space. So now I can go and commit this, commit. Okay, good. So now I've committed it. Adds this change. Hopefully this now passes. So you can see every time I make a commit, then now there is a new run that's being done. Okay, and hopefully this is going to pass. Yeah, okay, cool. So now it says all checks passed. Great. So now everyone is happy, all the tests pass, and now we can finally click Merge Pull Request. And what I highly recommend doing is, because they're kind of all, there's all these commits right here, right? There's update main, update readme, added more. These are not really great commit messages, and I feel like they will kind of clutter up your main branch. Like if I look through the commit history of my main branch, I don't really want to see all these like weird little like commit messages. So what you can do is you can squash all of your commits into one single commit. So in your main branch, it will look like you just made one single commit, and that one single commit was like perfect right from the start. And so this function right here is it's kind of the standard for anyone ever accepting pull requests. Instead of just clicking merge pull request, you actually do squash and merge. And what this will do is, it'll take all the commits, squash it into one single commit. Now if I click squash and merge, so it shows me all the commits, and it now gives it this name, added more documentation, which is the same name as this title up here. Okay, I click confirm. There we go, so it's merging, it's all happy, successfully merged and closed. Great, so now we've merged it. If we go back to our main, then now we can see we have successfully added this more documentation commit, and and there's only just one single commit for this because we have squashed it. If I want, I can still expand this out, and I can see all of like the previous commits, but like I would have to expand this out. So cool. Okay, feeling good? Good. Any questions? So let's do one more pull request, right? Let's pull in this this group mate number 2's changes as well, right? So here's group mate number 2's changes. They just added hello. So let's do that. There's going to be something kind of crazy here, right? Because what happened is we added this hello message, but it was right in the same exact spot as the message. And so because of that, we're going to have something called a merge conflict. Okay, people heard of merge conflicts before? Anyone experienced a merge conflict? Okay, anyone know how to solve a merge conflict? Okay, good. So we're going to quickly solve a merge conflict. And I know what you're thinking. You're like, oh, merge conflicts, they take me like hours to solve. How are you going to do it in the last 12 minutes of class? So it's not too bad. I'll show you. Any questions up to this point, though? Yeah. Oh, so the branch, the Better Docs branch is still around, yes. It is not deleted yet. So if I go and list all my branches right here, oops, sorry. 1 second. Yeah, so right here, I can actually see all of my branches still. And I have this Better Docs branch. But if I go back to my pull request, so I can go to my pull requests tab right here, and you'll see there's nothing here because I need to click on my closed pull requests. So if I go to this, then now I can see this pull request I just made, and and then there's this message right here that says successfully merged. If I want now, I could delete this Better Docs branch. And in fact, I would probably just recommend this because you don't really want to work off of a branch that has already been squashed and merged. So so in this case, so actually let's delete this branch. That way no one can accidentally start working on it again. So good, so I just deleted this branch and we're all good. If I go back to this, then you can see now it's gone. We just have Better Docs 2. Okay, good. Any other questions before we get into the last little haul? Okay, feeling good? Okay, it's exciting. So, good. So now let's switch back to Better Docs 2. Okay, so now we're on Better Docs 2. If I, oops, sorry, 1 second. Okay. So if I go back to the GitHub, then what you can see is for Better Docs 2, it is also prompting me to create a pull request. So I will do the same thing. So I'll click Create Pull Request. Okay, and I'll give it a better title. I'll say More Documentation. Okay, and Create Pull Request. Good. Okay, and we see an issue. So it says this branch has conflicts that must be resolved. Okay, and there are a few ways to solve merge conflicts. So we could do it entirely within GitHub. And actually, I usually don't do it through GitHub, but you can see, so I just clicked merge conflicts. And so now it pulls up this nice little editor. And what we can do, I think if we click on this, I guess it doesn't. That's okay. Well, what we could do is we could go and type this out. We could choose exactly what we want here. So maybe what we want is for, like we could just come in, I think we can just delete this, right? Yeah, so we can just delete this, and we can now just accept both changes. So we could now say, like, take a look around, and then hello, then take a look around, enjoy the weather. Maybe we want to get rid of this first. Yeah, maybe this is like the intended kind of result of adding this hello. So this is now our new change. Like before, it was like main at the moment just has this, right? So this is what main currently has. But now we are changing our commits to now include hello. Okay, so let's now click mark as resolved. And now we can commit this merge conflict. And there we go. So now it has added this new commit right here into the commit history, merge branch main, it's better docs. And now it is rerunning the test, and yeah, we don't have any sort of merge conflicts. So the merge conflict happens whenever two people, like on two separate branches, try to edit the same line of code at the same time. So that is what a merge conflict is two people who are trying to change a line of code at the same time. And so what needs to happen is we need to have like a mediator. Someone needs to determine exactly what that new line of code should be, because it's hard to tell what it should have been. Kind of interestingly, if two people were editing maybe the same file, but someone was editing maybe like a function like at the top of the file and someone else was editing a function at the bottom of the file, then Git has several built-in algorithms to figure out exactly like what was changed by each commit. And so most of the time you can actually just avoid merge conflicts altogether, as long as you just don't edit like the exact same line. Even if you're editing the same file, usually Git will figure out how to merge them properly without any sort of merge conflict. So Git, especially in like modern Git, there's been, I think, more recent advancements in merge algorithms. So yeah, kind of cool stuff. Okay, there we go. So we've now fixed the merge conflict. If we want, we can just click squash and merge, and and this will now fix everything. So good. So now we've added this final commit, and and it's good to do squash and merge, because now we can hide this kind of gross like merge conflict here. So now no one has to know that we accidentally created a merge conflict. Now we've clicked squash and merge, and now if we go back to the Git history, then yeah, you can just see that now it's called changes, which maybe should have been named a better thing than just changes. But there we go. Okay. The last thing, I want to spend a second talking about continuous integration again. Any questions on this example? Feeling okay? All right. We'll probably spend a little bit more time talking about Git throughout the quarter, so it's okay if you're not masters now. I will say on Canvas, I posted a quick tutorial on how to resolve merge conflicts. So you're welcome to look on that tutorial, and that should also help you in case you forgot any of these steps. So feel free, to go on Canvas and do that. Okay, I want to show you one more thing. So. Good. So this is the file analyzer solution. Okay, this is what the instructors have been working off of. You can see all the contributors here, and you can see like all the commits that I've made and whatnot. But if we go into the .github folder and open up workflows, so we can see all of the different workflows that are constantly being run on this. And so if I want, I can go into the build Linux workflow. And so you can see that we have, as the first thing, we have on. And on specifies exactly when this job should be run. So if you remember, continuous integration is the idea that you have some bit of code that is run on like GitHub's servers, or if you're hosting your repo somewhere else, maybe it'll be someone else's servers. But yes, specifically in this example, GitHub will automatically run all of these scripts for you. And here we're specifying when it should run the scripts. So for example, it should run the script when we do a push, but it should also run the scripts when we create a pull request and when we are updating a pull request. And in this case, I have this workflow dispatch method, which is just saying that I can go into the workflow, I can go into this actions tab right here. If I go into this actions tab, then I will see a little button that's rerun this. I think right here, right? I do it. Yeah, so I get this little box right here that says rerun all jobs. So that to me is very useful. So therefore, I add this little workflow dispatch. And then we can see all the things that are run. So here, it's installing CMake, and then it's running make dir build, cd build, CMake, and then make whatnot. Yeah. And so GitHub Actions, they're super powerful. Here I'm just testing I'm testing the solution. You can see I'm doing this run tests all. I'm testing everything. I'm testing my solution. This is absolutely what you should be doing in your final project. Is you should be testing all of your you should be testing your emulator code against the tests that you create. And then I can also go into the release GitHub action. And you can see, so this is slightly different. So instead of all of those times of running, releasing, instead I'm only going to release whenever I push to main. This is so that I don't clutter up my releases tab. And I give the permissions, I give writing permissions. And then, here I'm installing everything. And then I make the assignment. I know in the homework 4 starter files, I think I accidentally added a bug. But there's a Piazza post about that, so check that out. Okay, I'll probably fix the starter code as well. Had to do with the order of specifying the tag name. But anyways, so then we can see that I'm now uploading all of the release artifacts, specifically using this project that whoever this random person is. This random person created this cool project that lets you release things on GitHub. So I chose to use their project in this case, and I was also using it for the starter code for homework 4. So cool. So this is just a quick little overview of what GitHub Actions can do, and what I highly recommend. For me, I use GitHub for everything. I store my resume, my thesis, my research papers, when I design computer chips, I will put all of my code in GitHub. Everything that I ever do is in GitHub, and every GitHub repository that I have also has some form of GitHub continuous integration workflow on it, just to make sure that every commit that I push is correct. Because if something fails, what will happen is you will get an email sent to your phone, and it'll say hey, that commit that you just pushed was incorrect, and now everyone that is relying on this Git repo that you've created, everyone that is relying on it is now going to be disappointed because it doesn't work. And so getting emails is very kind of helpful to make sure that your code, you can go back and fix your code as soon as possible. Okay, good. Any final remaining questions? Okay. Anyone use continuous integration before this class? Okay, cool. Wait, actually, when did you use it? And shout it out. Anyone? Was it in another course? Yeah. Which course? 113. Nice. Yeah. Cool. Well, GitHub. Continuous integration is really powerful. It's not just for GitHub, but GitHub at least allows free usage of continuous integration, which is really nice. A lot of other continuous integration websites, you have to pay something. So, okay, cool. That is all that I had planned. Please enjoy your weekend, and I will see you on Monday. Please complete the quiz as soon as possible. That was just released. There's a quiz that was just released a minute ago, and and then on Monday we will have another in-class quiz. Okay, cool. Thank you.